Hi everyone. Today we'll be solving the day three lead code question for the 30-day lead code challenge. The problem states like basically you're given an integer array and you need to find the contiguous subarray sum. So in a way, the largest sum possible. Um, and so basically, for example, given this array minus 2 1 minus 3 4 minus 1 2 1 minus 5 4, if you see, if you take any contiguous subarray, the maximum possible sum that you will get will be from this subarray, which is like subarray from my 4 to 1, right? So how do we approach this problem? Simple brute force would be, you run, like, you take all possible subarrays and you try to find the maximum sum out of it. So basically that will give you the time complexity of O of n square, because you need to run one loop for I, which will be here, and then for j, different j, that will cover the other half of the arrays. So in a way it will be O of n square. So you will be running two for loops. If you want to find a brute force solution, that's the easy solution. But they are asking us to solve this question in O of n solution. Also, as a follow-up, they are asking if you can come up with divide and conquer approach, which is more subtle. But um, first we'll try to figure out an O of n solution. So let's look into this problem. Let me copy over the question here. It's minus 2 1 minus 3 4 minus 1 2 1 minus 5 4. Okay, so yeah, so now in order to solve an O of n, we know that we can iterate over this array once. But how do we achieve it? So let's look into the question to find some hints. So first thing, it says it's a contiguous subarray. So like we know contiguous means it's gonna be continuous. So if my array starts at minus 2, uh, I need to cover as much possible values I can till I can get the maximum, and I neglect all other values. So let's say I can't take like 1 from here, then 4 here, like that way I can take all the positive values and just sum it. So that doesn't means taking the contiguous survey. So contiguous means it always has to be continuous. Also, another hint we see is this array has negative as well as positive values, right? So in a way, so there will be a few corner cases, like let's say the whole array is of minus values. So in that case I need to take the maximum value, right, which is minus 1. There is no other possible sub array that is going to give me maximum sum, because sum of negative values is going to be negative. It just increases, right? Like if I take sub array from minus 2 to minus 1, it's going to be minus 6, which is not the largest sum that we need. So this is like a corner case in which, if all the array is negative values, we only take the highest value. But what if there's a combination of negative and positive values? So in logically speaking, why would I take or consider negative values in my array? In the sense, I would try to avoid as much as negative values I can, because they are bringing my sum down uh, in total, right? So that's not going to be a viable what you say option to pick. So let's say initially, my initial state, i take a variable sum. So what I'm going to try to use this variable is, I'll keep my ongoing sum of the subarray. So let's say if my subarray starts at minus 2, I'll be storing all the sum of values that start at minus 2 till the for loop which is at I, let's say -3. So I'm going to keep uh, my sum of the values that I have already traversed in this variable. So let's say initially I initialize it with the first value. I also keep a max one variable, which is for now I initialize with the first element. Right now I start a for loop from int 1 till I consider the size of the array as n, so I is less than n, I plus plus. So let's look now. So now as the new element comes in, so in our case, let's say in this example I get 1. So I already have these values, right? Sum is -2 and max is -2. Now one solution is I either add 1 to my existing sum, so I include this one into my contiguous subarray, or I start a new subarray from 1, right? So logically speaking, what would give me a more higher value? Like -2 plus 1 is going to give me -1. Would I pick -1, or is it better, because 1 is positive, to start my new subarray from 1? So why not an if condition where if my sum plus, I call this array A. Okay, so this is array A. So if, so I call this array. Okay, so if my sum plus array of I is going less than 0, right, is going less than 0, do I even have to bother to include this ith element into my existing sum array, or isn't it better to start a new array sum, like from the start? So wouldn't it be viable, I can make, if sum of example, let's say I just make the sum as 0, right? Because I don't want to consider this I don't want to consider this ith value with the previous sum value. I just want to start from the beginning. And also, what if there could be a scenario like this corner case where everything is negative? So what if my a of I was greater than my existing max? In that case, isn't it viable to update my max 1 to a of I, also to update my sum to be a of I, right? Because like I don't want to include it and make the sum negative, because if I try to add it to the existing, if it's getting less than 0, then if I keep moving forward, this negative value is anyways going to bring my largest sum value down. So I'll try to avoid considering any negative values. So this condition takes care of that, right? Now moving forward, let's say now my I'll take a different color sketch. So if my now array my starts at 1, right? So now my sum is 1, max is 1, right? What will happen when -3 comes into play? Again, -3 comes into play. -3 is bringing my sum down. I make the sum 0. I initialize it to 0, right? I don't care about sum, right? And my max stays at 1 itself, because I don't want to include -3 to my sum, because it's going to be -2. It doesn't make sense. So I keep my max at 1. I make the sum 0. That's it. Now when the 4 comes, right? Now when the 4 comes, my sum is 0, because I have broken the chain, right? Because we are talking about contiguous subarray. I cannot take 1 and then I can add 4. So like my contiguous subarray has been broken. So my sum is 0 now. Now when 4 comes into play, in this case, this will go into the else case, right? Let me take. So it's gonna go into the else case, right? Because sum which is 0, right, at this point, plus 4 is greater than 0, right? So I'm gonna go into the else case, which is like I don't come under this condition. Now one scenario is I can start a new contiguous subarray, obviously because sum is 0. So I can check whether my a of I is less than is greater than sum plus a of I. So this will cover the condition where if suppose even like let's say given an example -2 3 1 3, right? Let's consider this example. So in this case, what will happen initially, my sum is -1, m1 is -2, sorry, -2, sum is -2. Now next time when I come, it's -2 plus 3, which is 1. So this condition is false because it's not less than 0, it's obviously greater than 0. But in a way, what if, because it's obviously positive, like the sum of these two is positive, but if I just blindly can take this positive and keep on adding more values, the total sum at the end of this whole array is 3 plus 3 6 7 7 5 5. But what if I would have taken this part, that I would have started this new subarray from 3 instead of -2? I know -2 plus 3 is positive, but isn't it make sense to start it from a much bigger value? So this condition is going to check for that, because that even though sum plus a of I, which is -2 plus 3 is 1, and but my a of I is 3, I would like to start from a of I, which is I would like to start from 3, right? So I have this condition, I update it to sum is equal to a of I, right? Now another case would be, if this is not the scenario, just simply I'll have another else, which is just simply add sum equal to a of I, like just simply add this value, because like the whole element is not greater than sum of a plus I. It's better to just add it, right? Simply add it. Cool. And at the end of this, inside this else, I would obviously keep track of my max value, which is going to be my max of m1 is keeping track of any previous max value, which was 1, comma sum, right? So I think this covers most of the cases. Let's try to code it and see if this approach is gonna work. I'm gonna, okay, so I'm gonna need this screen maybe just to see. Yeah, this is better. Okay, so update two variables. I need to initialize it to the first value. Zero. Now I start from the first value. Okay. Now I'm gonna check, as I said, is sum. So if sum plus is less than 0, so I just break the contiguous subarray that I am considering till now, and then I check if a of I is greater than 1. This will cover the case where my array is all of negative values. So I just make it a of I, and I initialize sum to have a of I. Sorry, it's nums of I. Took a and make sum. Now we'll go into the else case. As I said, what if I still need to break, like even if the sum, adding sum plus new element is greater than 0, still I don't want to consider, because let's say we took this example, -2 plus 3 is 1, but you saw that if we start from 3 1 3, my sum would be much greater. So I just don't want to I just want to keep that option as possible as well. So if my it's more better to take new value with the new starting point. Otherwise I just simply add it, like if the value is not less greater than sum plus nums, just simply add it to the list, and then at the end I keep track of obviously n1 comma sum, right, and we return let's see, let's run the code on test. Oh, okay. Yeah, in the example I took it as a, so okay, cool. Fingers crossed. Okay, cool. So it seems to be working. And now, okay, now it says this was the offense solution. Now it says divide and conquer approach. Let's try to brainstorm that as well. I'll take let me write the numbers again. It's minus 2 1 minus 3 4 minus 1 2 1 minus 4 minus 5 4. Okay, so divide and conquer obviously reminds me that we are going to break this array. Let me take a smaller example, minus 2 3 1 3. Okay, so I break this into 2, so I get minus 2 comma 3, and then I take 1 comma 3. Then I split it more further. It's minus 2, it's minus 3, it's 1, it's 3. Okay, now when I return it, I just see for this part, inside this part, like my options are either I take the sum of these two, which is minus 2 and 3, which is 1, and then this is minus 2 and minus 3. So like out of this sub array, I should get the maximum output as 3. Also I need to make sure that 3 is the boundary array, right? Like it's on the rightmost part, so I can add this rightmost value with the highest of leftmost value from this array to get a new value, or else it could be this big value. In this case we get sum as this one is going to be 4, right? Yeah, so this whole array is returning 4. 4 is, you can think of it as a whole array. So 3 plus 4, so whole array is 7. Yeah, so I think somewhere around this, so we need a way to keep track that this is the leftmost sorry, this is the rightmost maximum sum of the subarray, this is the leftmost maximum of this array, and this is the whole of this array. And then because right of the subarray plus left maximum left of this subarray can be added, right? Because then they become a contiguous subarray. So I guess this could be done using recursion. I'll try and see if I am able to like find a solution in terms of code, but I guess our approach for divide and conquer should be around this. So I think the overall time complexity will be around O of n log n. But yeah, it's not better in compared to what we've coded right now, but it's a good thing to have like idea about how we can do it with recursion as well. That's all for today, guys. Hope you all like this video. Please subscribe to the channel and don't forget to like it. Thank you.